Yeah, okay, please start your timer now.
Okay,
Okay, I
started.
hope. Okay. Good afternoon, everybody. My name is Anandas Venugopal Madhav. Today, I would like to present a topic on AI-driven eco-friendly email management for enhanced productivity in the automobile industry. Now, my presentation comprises of 8 parts, starting from meeting my client until conclusions. Let us see one by one. Let me introduce to my client. This is Mr. David.
Hi, hello, my name is David Oon. I work for Continental Automotive Singapore. I have some email issues. When I look at my mobile, I scroll through my email box, I see a lot of emails. Can you please rank them so that I understand which one to reply? And my next issue is, can you help me categorize my emails? Segregate my emails into various categories. Thank you.
So, my Mr. Client needs business value for his problem. He wants to save cost and optimize his time. So now let us see the problem statement. Dr. David Oon is currently grappling with several email management challenges. And to improve it, he asked me to work on 2 things: email ranking based on urgency, that is to develop on top of Dr. Woon's inbox. And then the next one is multi-classification of emails, that is to implement multi-classification system for his emails, categorizing them into distinct labels. The classification will provide a structured approach to email handling. Let us see them one by one later in the slides. Now, if we look at the data set itself, my data set comprises of several columns. It is typical email. When you open any typical Google email or any email, you will see the same to list, from list, the title, the subject list, which is also content, and then the date list, label, and the file. The label here is the output, and the rest of the things from to date are my input. So if I have the input, I need to give some decision or some prediction on my label. So that is whole my target. Now here the assumption is that synthetic data was adopted for modifications because of the nature of the task assigned, and the CC/BCC was not considered. Only 2 I'm considering. The first and foremost, the challenge is to provide ranking. Now, what is basically ranking? We most of the time we know that Google or any type of service provider, they come up with some type of ranking system. Here I take an example of Network X ranking system. Just imagine, Venu, that's me having friends with Eric and Krishna, and Eric is having friends with Venu, Emma, and Regina. So just imagine in my colony there are many friends. So I can draw a network of friends and popularities. I can say who is more popular based on connecting the dots, friend of friend, friend of friend, in that way. So this is a basic network X Python based library which we can incorporate into our programming to actually come up with some type of ranking. However, when we say customized email product, then that is, we are looking at a person. For example, if you're looking at me, Venu, then the emails which are sent from me and which are coming to me are the important things to look at it. So that is what is called customization. So our first target is to address the ranking. And the next target is to do the multi-classification labels. So my client's email has 9 labels actually, required responses until job seeker. Now let us see what they are. Very quickly, the first one, required response, emails that require response from David. They are important and he has to reply. And then the emails from his boss or higher ups, these are definitely prioritized email for David. And then emails coming from his subordinates or his teammates. David should respond to mails for effective communication within his team. And the last one is job seeker. David may not necessarily respond to these, but instead he can forward them to appropriate department or HR for follow-up. And the rest of the labels is sent labels, sent to boss, sent to sub, and then the time based, which are basically the spam mails or the other type of mails coming from boss, we can ignore for a while, but basically we're trying to classify his email box into 9 categories. Now, if we look into the data, you can see that most of the data are between 2000 to 2005, the timestamp. However, I modified, customized it, and then I have added synthetic emails between 20 to 23. So this is how the timestamps of my email data looks like. And the final email set, that is the data frame characteristics, comprises of, as I said, my concentration is towards David. So I'm looking at the email senders, top list of email senders, and the top list of email receivers. So that is how I arrived at my data. So first I considered Enron data coming from Kaggle, and then I modified it to specifically address my client. And the thousands of emails coming to David are coming from few selected domains. So starting from Smart Continental Company where he is working, and then there are many email domains. So now the ranking, as I said, we can either have a generic ranking system or a customized ranking system. Here, David want to use some urgency list like soon, short, urgent, pressing, and more importantly, his boss is Vincent, capital V Vincent, short P, small letter V Vincent. So basically, he gave me his priority or urgency list. So when I use urgency list into the system and when I don't use, you can see a difference between the ranking system. For example, David tells me that 70% of the time he's looking at the wrong email. That is because he looks at the blue emails where the company says these are the email IDs, these are the emails which he have to address. And here are the x-axis shows the emails coming from the senders. And then the blue lines shows the prioritized email based on his existing email box. And just imagine, now if he focuses his attention on saffron color, he will save 70% of the time. That is how the ranking can help individually in saving a lot of time. Now you can see just a small example like before and after, like first using baseline network programming and then using customized can really prioritize. David is always at the figure like number one here because he's the client. So if somebody else is the client, then obviously the ranking will shift and that somebody will become the first. So that is how we can customize. Now, in the second problem, multi-classification, I realized that some observations are very low. That means some categories are very low. We saw there are 9 categories, but some are very low. So we can drop few which are very low because we need significant data to train. So we need to apply binary at each label, yes or no, for each label separately. And the assumption is that we can drop all those observations which are low or all those labels which are low. As synthetic data was adopted because of the nature of the task assigned, the accuracy, the precision, the FN score could be lower. Now, the data typically, like I can say that I have 5 independent variables, 2 to date, and then 1 dependent variable that is label. So now during modeling, first step is to do pre-processing. That is to remove punctuations, additional spaces or special symbols. And the next is to remove the suffixes using quarter stemmer. So that is basically trying to customize this or just get a text out of it. So we only want the text with all the words. So you can see the word cloud, which shows the customized email information where David is appeared more number of times than his own company probably. And then right side shows the term frequency inverse document frequency score of certain words, where certain words appear more number of time in the emails. And I have used 5 models. And I have actually like 6 categories to address. That means I have ignored few which are very less. I spoke to my client and I realized that, yeah, without significant number of observation, we can really not work out or improve the accuracy. That's why I limited my observations only to six categories with 5 classifiers. Now let us look at each classifier separately. Now the first one, the supervised learning model, a KNN classifier, the average accuracy is 0.56 with the F1 average is 0.45. And if I look at the support vector machine classifier, this seems to be much better. I see the accuracy is improving. It is 0.62 and F1 score is 0.62. And you can also look at precisions recall for each and every labels separately. And the third one is forward neural network. Some of you may have doubt that title and subject list may be dependent because that most of the time title is dependent on the content of the subject. So there is a chance that people will think that FNN could be better, and even I feel so. So I especially looked at it at each and every category, and I realized in future this can be used for modeling his email box later on. But anyway, if you look at the other models, the decision tree classifier, the result is not so good. I used random forest classification. This seems to be little better. So out of the five, SVM gave me the best average scores. However, I still feel that FNN is a better option because title and subject are interdependent. So path forward synthetic data should be changed with the real-time data for improving accuracy. The two tips what I can give is email ranking together with multi-classification can be adopted for individual email boxes. The condition is individual email should be used for training purposes. So machine learning obviously increases with volume, and the business goals and solutions what I have arrived at, it improves David's email management system basically to the left side, and to the right side what I say is his ranking will be improved, the email ranking will be improved, saving of time. He can forward unnecessary emails or job seekers email to his subordinates, and he can create auto reply option for non-urgent emails. And for his organization, it has a potential to save 31% of the salary every day. And what we are looking at email and how much 180 minutes is wasted, with at least 31% of salaries wasted. And who will benefit? Employers like David Oon. And we are adding a layer on top of existing email system. We are not completely closing his email box. We just add a layer on it. And the statistics says that 544,000 man hours are wasted by this company worldwide, with a loss of at least 700K per day. So which is huge. So if you just look at two examples, I can say at Brazil, we can save 4,000K every day, and at Japan, we can save 15K every day if we just think of saving 30 to 40% only. Just imagine if we continuously get the data from the user and try to train the model, improve the accuracy, the saving can go up to 8K at Brazil and up to 29 to 30K at Japan itself. So each and every location, we can try to reduce the losses for the company. So references, I got the all the data and the information from the following links, and I thank Safar, Eric, and my classmates, and thank you all. This is my presentation.
Okay.